And this basically has to do with multiplying things together or factoring things. And the idea behind this is going forwards, if you have something, I'll call it A plus B, and I multiply it by A minus B, do you remember what happens to the outer and inner terms? You don't? Okay, so what I want you to notice is, do you see how these are exactly the same? And these are exactly the same. What's the only difference? The sign in the middle, one's plus, one's minus. You're not doing this because from now on I want you to recognize this. That's a squared. This is minus ab. This is plus ab. This is minus b squared. What happens because of those signs? What happens right here? They cancel. And that is always going to happen because one of these is a plus and one is a minus, as long as they are identical. So as long as it's an A and a B. All right, so let's do one. Let's do one. Kim, are you okay back there? Move up.
The projector just sucks in this one.
It's really, okay, in the back it's really bad. Is this better if I go like that? No, that's better. Allegedly, it's worse in my other room. That's what the kids keep saying. Is that better? Is that a little better? No. They're like, no, it's not. All right, so let me give an example, and then we'll move on to our next one. If I asked you to simplify x to the fourth minus 3 times x to the fourth plus 3, what we want to start working towards is just recognizing it and knowing. Now, is it the end of the world if you add the middle terms together and do that? No, it's not, if you're not sure. But we know this happens, so I'm going to not even write it down, the outers and the inners. Okay, so what's x to the fourth times x to the fourth? Say it to the person next to you. X to the 8th. Okay. What happens to the outers and the inners? Cancel. What's negative 3 times 3? Minus 9. So I want you to recognize it both forwards and backwards. Forwards is multiplication. How do we go backwards with polynomials? Starts with an F. Don't remember. What if I asked you to factor? All that means is if I give you this, put it back into the multiplication. So let's go backwards this time. Let's factor m to the 8th minus 9n to the 10th. So do you notice it's a difference? Okay, how can we tell when it's a difference of squares? Well, you're going to be able to figure out something that multiplies by itself to give you m to the 8th. What could you multiply by itself to give you m to the 8th? Turn and talk to somebody around you. What do you think is going to go in the first spot? Talk to somebody around you about what you think is going to go in the first spot. Wendy, what do you think? Did you talk to Taylor about it? Okay, I think it's safer to talk to somebody next to you. That's why I'm having you do that. Because you guys aren't like talking to me, which I get it. That's intimidating. Talk to somebody around you. What do you think it is? Gabe, what'd you guys say?
I put m to the 4 minus 3m to the 4.
So m to the 4th times m to the 4th gives you m to the 8th. You're right. How would I get a 9n to the 10th? You said what? 3?
And 5.
Yep. And then what symbol do I need? Plus and minus. Does it matter which one's which? No, because they're identical. Okay. All right, try another one. You guys try this one now. What if I asked you to go backwards? I'll call it factor. 9x to the 4th minus 25y to the 6th. All right, try to do it and then compare with somebody around you. All right, take a peek at the person next to you. Abby and Skylar, you guys can compare since you don't have partners. Let's see if we can come to a consensus. All right. Logan, what did you guys say?
We put 3x squared plus 5y to the 3rd. And we did the same equation for this one, except the 5y to the 3rd is minus.
All right, who got that? Okay. That's difference of squares. So today I'm going to ask you to go forwards and backwards. Okay, an easy way to tell is going to be that there is a subtraction sign there. There is no sum of squares. No such thing. So I won't ask you to do that. Someday I'll talk about, there's one for cubes, but we're not going there today, okay? All right, difference of squares. Second polynomial identity. So we are only doing 2 today. The second polynomial identity is called, got a longer name, a perfect square trinomial. The perfect square trinomial is the thing that was number 3 on that SAT paper I gave you today. And that's why I said, hey, if you want to hold off on that, that's fine. Perfect square trinomial is, think of what a perfect square is. Perfect square are the numbers like 1, 4, 9, 16, 25. What's the next one? What's the next one? 36. What's the next one? Brian, what's the next one after 36? Do you know what I'm doing right now with these or not? So here I said 1, 4, 9, 16, 25, 36. Corey, what comes next?
49.
49. Tate?
64.
Okay, how am I getting these? Wendy, how am I getting those? Don't know. Soraya, how am I getting those? What's that? Multiply by itself, right? 1 times 1, 1 squared, 2 squared, 3 squared, 4 squared. Okay, so you do need to be able to identify perfect squares. In algebra, we got all the way up to like, I think 144 or something like that. You should be able to identify them. So that's what perfect square means. So it's going to begin with a perfect square and it's going to end with a perfect square. And it's a trinomial, which means it has 3 terms, okay? So here's a perfect square trinomial. Arises when you have something like this. A plus b squared. What does a plus b squared mean? Doesn't it mean a plus b times a plus b? Okay, when you multiply these together, you get an a squared. That's a perfect square on the front end. When you multiply a times b and a times b, there are 2 identical terms. Do you remember how the last time they canceled out? If there are 2 identical terms, we just double them. So ab plus ab would be 2ab. So a squared plus 2ab, and then finally plus b squared. So you could memorize these by looking at these and realizing, hey, that's that squared and that squared, and if I multiplied a and b together, that's that term doubled. What do you think then? What would be the only difference if it was a minus b squared? Aiden, what would be the only difference in that? Oh, 2 Aidens. I got 2 Aidens. Either one.
Oh, sorry.
No, you're good. You say it. You started first. The 2ab would be?
Minus.
Yeah, the only difference would be the middle term would be a minus there. Okay. So perfect square trinomials are our second type. Okay. So, suppose I give you then something like this. 2x squared plus y to the third squared. Okay, once again, guys, if you are unsure, put them out and multiply them together to check your answer. But I'm trying to show you some shortcuts, some ways that it makes it a little easier. This is one of those perfect square trinomials. The result, anyways. Okay, so the first term is going to be this term squared. What does it mean to square? Multiply it by itself. What's 2x squared squared? Or 2x squared times 2x squared? What would that give you? 4x to the fourth. The middle term, for our shortcut, the middle term, we're going to multiply these together and double it. So 2x squared y cubed doubled. What's double of 2x squared y cubed? 4x squared y cubed would be our middle term. And our last term is this squared. What's y cubed times y cubed? It's y to the 6th. So that's how you would use the shortcut when multiplying. I'm going to pull this one up from earlier. Let me show you how it would look like if it was factorable. So let's say I had 9a to the fourth plus 12a squared b squared plus 4b to the fourth. And at first you might think, well, that's overwhelming. Here's a key to this, guys. If it looks like there's a lot of large numbers, the very thing I would always try first is let's look at the beginning and the end, and we're going to ask ourselves, are these perfect squares? Is 9 a perfect square? Yes. Is 4 a perfect square? What about a to the fourth? Can you multiply something by itself to get a to the fourth? What is it? A to the second? Okay, so let's look at the middle term then, and let's see, what is the square root of 9 if this is going to work? Say it out loud. 3. What's the square root of 4? 2. Okay, so I'm going to put a 3a squared, that's the square root of that, 2b squared. Let's do a check. When you multiply this, don't you get 6a squared b squared? Isn't that doubled? Yep. So this is a perfect square trinomial. That's a plus sign because this is a plus sign, and it's a squared. Who needs to see another one like that? Not getting anything from you. Come on, guys. Do you need to see another one or you got it? Okay, we'll do one more of those. How about 25x squared plus 40xy I have to think hard here, plus 16y squared. Okay, so we check. Is that a perfect square? Yes. 5 times 5, right? And an x times an x. Is that a perfect square? Yep. 4y and 4y. This is a plus sign, which means this is going to be a sum of my square. So we have 5x plus 4y parentheses squared. And then we always want to double check that middle term. If you multiply this together, don't you get 20xy? If you double it, do you see that that's 40xy there? Okay.